Okay, so once again, you are mostly welcome. My name is Mtanda Samil. Now, without wasting time, we are in for item 6, or the last bit of our Wakissha paper. Of course, you all know that a math exam, standard 1, new curriculum all level, must have 6 items, and at least we have been able to clear them to this last item 6. Okay, good. Now you realize that, please, as you're watching item 6, we simply remind you that we have written from item 1, item 2, item 3, item 4 and 5, then 6, where we are right now. So get time, you go there and you enjoy written from item 1, such that you are informed on which areas did they set in here. Please, they may not necessarily bring back some of these questions in your name, that cannot happen, but they can bring something, a resemblance. Say, for example, maybe item 6 talks about what? Item 6 talks about 3 dimensions. Then your name may also set on 3 dimensions. And please, the disclaimer I want to put here is that, please, I only discuss questions from any mock body. Of course, I know now people may be like, it's all about Wakissha only. Not really, please. We can as well discuss Wakissha, we can discuss Umuta, we can discuss Kasek, we can discuss ITEL, we can discuss, okay, whichever mock body you know of. And of course, if you have any which you want to us to discuss here, you can send it forward. But maybe a simple reminder is that, please, as a team, Teacher Mtanda, we have our technical team which uploads this work here, and they have got arrangements. In fact, you realize that in the studio we have over 30 videos ready to be uploaded. So if you share a paper or a question, please, it may take a bit some time to be uploaded, but unless otherwise, I can just help you as a person and maybe we share pictures, because it's very hard to share videos on WhatsApp. I don't know whether that makes some sense, but I hope you really come to understand that. Okay, now here, what you're going to do in simple terms is, before we go into this question here, remember item 6 is also another good one. Please, I want to show you what item 6 is all about. 3 dimensions, a sensitive one, and of course you must watch the video at the end. But then just know this is what you're going to have in front there. This is what you are going to look at. I'll always be giving you a quick glance on what we are going to have ahead there. So simply, here it is. Okay, so you realize that that's what you're going to have right in front there. So don't really miss out to see how that comes about, the pyramid, the cuboid. Okay, how do you find the number of pyramids in what? Anyway, this was Wakissha 2025. Please don't miss out. Watch to the end, and also please share the video to whoever may find it important. Okay, so without wasting time, I think let's start off. Wakissha item 6. We read it off. Okay, yeah, we remind you to subscribe. Please, your subscription is the only token of appreciation you can give to us. You call for your cooperation by sharing, like, and also comment on the video. Of course, I know the comments tend to be hectic to some people, but you can just simply hit the thumb or the like button only. That is enough. Get that out. Anyway, if you can comment, well and good. Okay. I don't feel like mentioning some of your names here, but there are some people who always coming to comment, and I know you by the way. How I wish maybe someday we meet in person. Anyway, yeah, by the way, still this can go as a reminder. Please, you can as well agree. If you're a teacher, you can like call for our interaction in your school. You can call us such that we can come in and interact with the students, such that we share ideas. Please, we don't only prefer to share ideas here on the channel, but also physically with the learners. Or if you're a learner, you can as well hand in your request such that you can come around and we maybe have something touched physically, such that we make education fun. Alright, because there's not a war, there's always life after this. Alright, so with that, let's start off with our question. Okay, good. So our Wakissha, now to avoid the someone requested I bring it in black and white. Anyway, I don't know if that makes some sense. Okay, someone requested we may make it in black and white. Please, you give me a comment if it is really work out for us. Please, if it will work out, you give a comment there you give us a comment. In fact, if it will work out, you give us a comment. You let us know if it will really work out. I don't know. So rate a comment if black and white will work for us in the question part only. The question part black and white, then the other side we maintain our original display. Anyway, item 6, here we go. Alright, so they are saying your sister, oh, what's wrong with this? Okay, let's go into this. They're saying your sister works as a production manager of a company that deals in manufacturing of school laboratory supplies. The company has received an order. Oh, I don't know what is this. Why is this one disturbing us? Can't really tell. And I proceed. So they're saying the company has received an order of making 1,420 pyramids for a certain school. In fact, here I can even use this because it can easily be seen. Okay. The company has received an order of making 1,420 pyramids for a certain school. The school wants a pyramid, take note of that, a pyramid with a square base measuring 60 centimeters and slanting edge of 70 centimeters, right? Your sister must submit a sketch that is to be folded. A sketch that is to be folded. A sketch that is to be folded. Now, before I proceed, what you should know is that we have a subtopic, we have net, which we call a subtopic which we call what? Nets and solids. I don't know if you know that. So a sketch that is folded, it simply means a net. That topic is in book 2 about nets and so on. Hope you learned it. To make, however, even when you didn't learn, no worries, you'll understand something about that here. To make the pyramid that the school wants, but she is finding it hard. The company packs pyramids in a box. So the pyramids are packed in a box that measures. So the box measures 66 centimeters, 24 centimeters. They're using by, and of course, by like that. Okay, 24 by. Okay, now if you write in this format, it means that this one is a length, this one here is a width, this one here is a height. That's how they write. Okay, so to 6 centimeters by 24 by 15 centimeters, and the manager wants to know the number of boxes that will be needed to pack all the pyramids that the school wants, as there are only 5 boxes available in stock. Alright, great. The company manufactures and sells each pyramid at shillings 25,000, and the company manager receives a commission of 12% for the first 500 pyramids, and then 80% for on the pyramids excess of 500. Right. Your sister wants to know the total commission she will receive from the order made by the school. Hope that makes some sense. Part A, the saying task. Help your sister to sketch the diagram she is to submit. Now remember here, this sister of ours is going to submit in. This sister here is going to submit a sketch of what? A pyramid. But remember, she even failed to fold it, so she's just going to give us a sketch. I think a sketch that is to be folded to make the pyramid. Are you seeing that? So you're meant to sketch a pyramid right away in this Roman number 1. Of course, you all know a sketch of a pyramid. A sketch of a pyramid is like this. A sketch is more like a net. It's like that, triangular, rectangular base. We have that. We have this right here. We have this right here. And this right there. That's the sketch of what a pyramid is. Anyway, remember number 2, how many pyramids can be packed in the box? We shall see that. Are the available boxes enough? Remember, there are 5. Are the available boxes enough for the pyramids ordered for? Anyway, we shall see. Obtain the total commission. Alright, total commission that your sister will get from the order. Please, it is a nice one. I would request you watch it to the end. Okay. And of course, if you're learning senior 4, please, I kindly advise you that you must look into the mock papers, which different mock bodies were setting, not necessarily Wakissha only, but should really also look into other mock bodies, such that you never know, something may come. Not really the same way, but just a resemblance can be a topic. So for example, here we're discussing 3 dimensions combined with some business math, that is commissions. But of course, they may just mean to set something of the kind in your name. You never know. They may set a resemblance of that, and of course they enjoy. Now, make sure that on this channel you watch as many videos as you can, especially physics. You should watch as many videos as you can. You never know, you land on one which is even just exact. Alright, good. So without wasting time, let's proceed. Okay, now let's can see that sketch right there, Roman number 1, part A. So you're simply going to have the sketch drawn for us here. Alright, have a sketch drawn. Let's have the sketch drawn very fast without wasting time. Let's have the sketch drawn. I've already given you what this sketch looks like. In simple terms. Alright, we have that. Now remember, they said it was a square base, so those symbols mean that they are equal. No, they can really see something here. This symbol means that this side is equal to this side, and is equal to this side, and is equal to this side. That's what those symbols imply. So let's have the sketch drawn. That's a sketch of a pyramid looks like. Okay, in simple terms, that's what we have. Now, you realize that still this side is equal to this side, and this side is equal to this side, and this side is equal to this side. This side is equal to this side. Now the slanting length are these ones here. Remember, I said slanting length was 7 centimeters. Okay, anyway, I'll be putting that for you. Let's get there. So we have that 6 centimeters. Now we have that equal to that, equal to that, equal to that. Okay, where you're seeing double bars, everywhere you're seeing double bars, the value is the same for each part, and that value is 7 centimeters. So where you see double bars, you must put a 7 centimeters. Where you see single bar, you must put 60 centimeters in simple terms. Alright, since we are done with the sketching, so that's how a net. This the sketch was meant to make for us. That's the sketch was meant to do for us. Now if they ever ask you a sketch of a pyramid, there we go. And of course they may ask you for a sketch of, if they can ask you a sketch of a prism. I don't know whether you know what a prism is. A prism looks like this. I'll just give you a simple sketch here. A prism looks like this. So I'll just give you a simple sketch here. Okay. A prism looks like this. That's how a prism looks like. Now, what a sketch of a prism will just be in this format. A net, they call it a net, they can draw for you there. And now, a prism is an example of what you call a tent. They can bring a tent in 3 dimensions. So the sketch, a net of a tent, is right here. This is how it looks like. A continuation like this, another continuation like this, and then like that. That's how a net of a prism looks like. Hope that makes some sense. I'll raise it off. Then also maybe another format on how they can draw a net of a pyramid is like this. This pyramid here can be drawn like this. Just like you're seeing right there. We have a triangle there, we have a triangle there, we have a triangle there. Now instead of putting this side, they now come and add it onto this, and they make it like that. Yeah, they can make it like that. Now this side you're seeing here would be the one around this side here, but they decided to take it the other side. Okay, now that's the net. Let's go and see what next is required in this question. So they're saying, Roman number 2, how many pyramids can be packed in the box? How many pyramids can be packed in the box? Now, what we do here is, to know how many pyramids can be packed in the box, what you should know is, a pyramid looks more like this. In fact, a box looks like this. Just give you a simple sketch. Oh. Okay, I don't know. I think it is a network error here, but no worries, still we shall get there. Now, okay. So what you're going to do is, in simple terms, Okay, now if our box is like this one here is our box like this. Okay, I don't know where the error is, network problem I think, but I think here they want us to, okay, maybe I'll explain from here that if we have, say for example, the number of boxes, the number of pyramids you can fit in a box. If this is our box like this, please just allow me make funny sketches here to at least get this done. Now remember, here this box have got a length, we have got a width, and they have gotten a height. Then how is the pyramid drawn? Please, a pyramid is in this format always. A pyramid is in this format always, like this. So pyramid, oh sorry, let's call up this. Please, I'm really sorry, the network error, the network is a bit disturbing, that's why it's a bit jumping like that, but still no worries, shall get there. Oh, it's a funny one. I seem not to be accurate on this. Okay, I will have it erased. I want to get us a pyramid here so that you can learn what you are meaning here when they want to know which one is going in which one, other one. So okay, oh, it's a funny one, but just allow me leave it the way it is, assuming it comes like that, and this one also comes like this, and this one also comes like this, and this one also comes. In fact, it's really funny. Now allow me just write it down here. Anyway, I think let's just proceed. The network is a bit disturbing, guys, but still we shall move. Now here I'll repeat again. I think let's begin with the pyramid this time round. The pyramid, let's begin with the pyramid this time round. Okay, yeah, I think this one will come out. Thank God the network is a bit okay now. Alright, good, there we are. Okay, and our pyramid looks like that. Now on a pyramid, what must you know is that our box is like this. Of course, the box they're talking about is ever like this, a cuboid. A box gives us a cuboid. A box, they're meaning a cuboid. Okay, you remember in primary we used to just call it a box, not even a cuboid. So now here, this has a length, a width, and a height. Now here they want to know how many. Remember, this one here has 6 centimeters right here. This one has 6 centimeters right here. It has 7 centimeters right there. Now this one has the length as 66 centimeters, has a width as 24, has a height as 15. Now you really see that, of these two guys here, okay, look, this one is big. In fact, this one is big, meanwhile this one is small. So what does it mean? In order to get how many pyramids can go into this, can enter in here, like just imagine you are placing the pyramids in here. That is our pyramid, another pyramid, like that. So how many of them can fit in here? Now what you're going to do is that you come and compare. Say for example, in terms of length, you will say equals to, okay, now length of the cuboid is 66 divided by length of this, which is 6, like that. Then you go to the width. Okay, width of the cuboid is how much? 24. But again, remember this one was a square, so length is the same as width, so again 6. Then finally height of this one is how much? Is 15. Height of a cuboid divided by height of a pyramid. Now we don't have height of a pyramid. Height of a pyramid, h, is this line from here up to here. That h there is what we need in order to come up with our answers. And with that, let's consider that in the next step. So shall we begin by, alright, so without wasting time, let's go there. We find the number of pyramids we have right there. So with this, we shall begin with that formula there, that, okay, number of pyramids is equal to length of the box over length of the pyramid. I was explaining this. Why length of the box? Because the box is what? Big, and the pyramid is what? Small. So to get the number of pyramids, you divide the big over small. That's what we do. Now let's get our box drawn. Let's get our box drawn such that we can go on the comparisons. Let's get our box drawn such that you can really see the sketches right here, plus their corresponding dimensions. Let's get our box drawn plus their corresponding dimensions. Let's get our box drawn plus their corresponding dimensions. All right, good. So we had our length as 66. We had, okay, I think that is a technical error, but we shall get there. I told you about the networks of 15 centimeters. Okay. All right, now we get, okay, now just know that this one have it as 15 centimeters. I apologize to you had a network error, but no worries. We have that as 15 centimeters as a, oh sorry, this was meant to be, okay, in fact no worries, but okay, we shall call this one 24 for our own good. We shall call this one 24, no worries. Still, since now what we're going to do, remember I talked about a pyramid. So if you're talking about a pyramid, then you must, we're going to draw our pyramid and we see now on the pyramid what is missing. You remember from the other side I showed you that the height of the pyramid, you don't have it. Remember, we have to compare the length, we have to compare the height, we have to compare the width, but we have the length of a pyramid, we have the, in fact let me just get it for you here. Let's get a pyramid drawn here such that we can really see what I'm trying to mean here. Let's get the pyramid drawn. Please, we must be knowing how we, okay, must be knowing how we draw a pyramid. Must be knowing how we draw a pyramid in simple terms. Alright, so that's how we simply draw a pyramid. I've simply apologized, there have been a network error, but still shall get there, no worries. So that's how we draw our pyramid. Simply, you better learn how to draw a pyramid, please. You better learn how to draw a pyramid. A nice one, by the way, like we have there. So let's put in the values. 6 centimeters. Again, 6 because it was a square base. 7 centimeters. Alright, good with that. Now, we need to find the height of the pyramid. So, shall I say, I have 7 everywhere. So, that is our height h. In fact, our height is that line from here up to right here up. That line there, and we are calling it letter what? Letter H. And now what does it mean? It means, okay, allow me to resolve this. So it means that we are finding height. Why are we finding height? It's because on a pyramid, this one here is the same as a length. Remember, on this we have a, okay, maybe we have a length, and maybe we have a width, and maybe we have a height. Now let's look into this. You realize that, please, I told you that this height was given, it is 24 centimeters. It will come on later. I've told you it is a network error. So now here, now we must check, do you have the length? Yes, length is there. Do you have the width? We call this one width for that, for example. What is missing? We have length right there. Okay, length. Okay, let me resolve this. Okay, now we're asking ourselves, do you have the length? Yes, the length is right here. Do you have the width? Yes, the width is right there, like this. Now finally, this one is a height, and for this height here it is 24, maybe. Now this height is 24. Do you have the height? Not really. In fact, not really. So we don't have a height, so we need to find the height first of all. And I'll show you how do we get a height of a pyramid. Please, how we get the height of a pyramid is just very, very simple. And please, if you want to know much about a pyramid still, you can go in the playlist and check for Senior 4 activities of integration. Senior 4 activities of integration. There is that video in the playlist. Senior 4 activities of integration, you will check. The very last, in the video you scroll, the very last, in fact, back then I was making over 5 videos, 5 questions in one video, so it's a bit long, but you scroll up to the end, we have more work about the 3 dimensions, especially pyramid. Okay, now, since we have this, we need to get a height. But how do we get to get height of a pyramid? We always begin with the base. How? The height is got from this, that very height we have, okay, from there up to this level, like that. Allow me shade it for you. From there, that level back this height where I'm shading, back that height up, and again back up. Now what does it mean? It means that what I've shaded there, let me get a different ink. It means that what I've shaded there is that, okay, I want the height. Well, I have the slanting length, which is 7. Now, do I have this area here? I don't have it. But getting the area from here up to there, how can I get it? Remember, I can get it from the whole complete diagonal from here like this. So how will I get this area here? I will make an extract of the base. I'll make an extract of the base in simple terms. An extract of the, okay, an extract of the base. Now what does it mean? It means that when you make an extract of the base, it means that we shall draw like this, because now this other side which I want to find is part of the diagonal which is coming like this. Allow me shade it like that also. That diagonal, once we get it, divide it by a half. Now here it will be halfway from here to this side and from here to that side. Okay. Now our work is looking a bit untidy. Let's see. Clean it. Now that is it. Now we need the length from here up to there. But length from there up there can be got if you have the whole thing from here up to here. That's the diagonal. And now let's get our sketch. Now maybe put the letters there for simplicity. W, X, Y. Up there we have V, and in the middle we have O. Now since you have the letters there, it will be easy for us to internalize this. Now since you have here the O, what do you know? We want OY. Once you get OY, back to that, and the slanting, you shall have gotten the height H. Now shall we get that? What you are drawing here is our base, and I think let's get everything there. That is our base. I've already named it. 6 centimeters there, you can see, even back there 6 centimeters. Now our aim here is to get this diagonal here. Our aim is to get that diagonal there, of which halfway the diagonal from here up to here is a half, and from here up here is also a half, to get it completed. Okay, now with that I think let's proceed. We have W, X, Y, and Z. So let's get our diagonal drawn in there. Okay, good. That's our diagonal WY. Now, but remember, we want that point in there, the point X there of the whole diagonal. But remember, we shall split it into that format. Now, what I want you to see here is that, now I think the color here, this color is giving us another triangle in here. Didn't want to redraw? There are two different colors here, if you can really see. So if you are seeing them, then we are using those colors to have our triangle there. So we have the triangle W, X, Y, and we want to find it. Remember, you can call this to be your A, this one to be your B, and the hypotenuse is your C. So now we're going to use Pythagoras theorem to get a distance. Remember, you have this as our A, we have this as our B, and we have this as our C. So let's make the substitutions. There we are. Okay, after substituting, we have that. But now 6 squared plus 6 squared shall get a 72, still equal to x squared. And then what are we going to need here? Please, we shall need a square root, and there also shall need a square root. Let's have that in the next step. Square root of 72 is equal to x squared. Now this root goes out with that x, the square root goes out with that power 2, and then we shall remain with our x right here. Then a square root of 72 to 4 decimal places. Please, you must always write 4 decimal places. Is 8.4853 centimeters. That is our x. Remember, it's not over here. Our aim is to get WY. That's what we have. Now times a half will be able to give us the distance from here up to right there. Which distance from here up to there, back on the height and the slanting. We shall be able to get the height. So since we have gotten the, okay, since we now have the diagonal, let's now go on the next step. So in the next step, we're going to say, so we remind you that diagonal WY is equal to 8.453. But remember, we want OY. So OY is equal to a half times WY. If you can really see that, a half times WY. So we have, okay, a half times WY. But then WY was how much? WY is this. So we multiply by a half and we get the answer. Now, why are we multiplying by a half? It is midway. So when we multiply there, you'll have OY is equal to 4.247 centimeters. Please, I want to remind you a little bit as that is coming around. Please, why I multiply with the half is because from here up to here, say for example, if you have 10, if WY from here up to here is 10 centimeters, I'll give you an example. From WY is 10. So here it means that we shall have 5, and even here we shall have 5. Okay. And even here we shall have Even here we shall have our 5. Now realize that from here up this side 5, and also from here up the other side 5. Hope that really makes some sense. Let's, I think, get there. Now let's go. Now like we are, we have our height. Now like we are, we have our length, we have our height, and we have our width. Please, here this was meant to be our width by the way in simple terms. However, no worries, we shall just have to proceed like that. We have nothing to do. Let's continue. So let's go and start comparing. Okay, now remember we're still getting our height. Since now we have that, let's get this drawn. We did on our pyramid again. I would have used the other one, but for simplicity, let's get another one here. We're getting our pyramid drawn again so that we can proceed. In fact, okay, told you there's a network error, but no worries, still we're about to finish, no worries. Okay, now we get that drawn. I'm highlighting them for you to see which triangle we're going to use here. I'm really highlighting them for you to see which triangle we're going to use here. That is our height h, that's 4.2327, you can really see. Okay, then we have, okay, now we have there 70 centimeters for this area here. This area here is 7 centimeters, like there. Now that triangle is what I'm trying to pick out here. Okay, from here to here is 4. Now this 4.23 is this one here, halfway. Remember the whole line from here up to here was 8 point something, but now we wanted from here up to right there, which was divide time was a half, and it gave us this which we have right here. And when we transfer, you have this, that. Our aim is to get to the height there. So still here is Pythagoras theorem. When you substitute in the Pythagoras theorem, what will you get? Our height h is there, this one is there, equals to 7 squared. Let's get this harmonized. So you're going to have h squared plus, when you have it computed, you'll get, so this one here squared will give you that, 7 squared will give you 49. Now we go about this one and crosses the equal sign. Remember it was a positive, so it becomes a negative. Use a calculator. Your h squared will be equal to 31.084. But now we need the value of what? The value of h. The square root on both sides. Okay, now this root, okay, allow me to cancel please. Okay, this root goes out with that too. We remain with the h, so square root of 31 will give us a 5.5753 centimeters. Okay, now since we have everything, we are now good to go. Remember, we have our length, we have our width, and we have everything. So what are we going to do? Okay, let's, I think, proceed. Now what you must know is that about the box, you must know this. About the box, you must know that the length is 66, and about the pyramid, okay, the length there is just originally 6 because it has a square base. The length there is originally what? 6. Okay, now let's see. We first of all compare that. Maybe just to remind you that number of pyramids along the length, that's what we want to find. That will give us length of the box over length of the pyramid. Why are we starting with the box up? It's because the box is big. What is big is what you put up. This one here, the box is big. You know the pyramid is what? Small. The pyramid is small. Okay, now with that, I think let's proceed. Okay, now you really see that from here. I think that the box value is 66. The length value is for box, length is 66. For pyramid, length is 6. So let's make the substitution. So number of pyramids will be equal to, along the length, how many pyramids can fit in the length? So 66 divided by 6, and that will give us number of pyramids along the length will give us, this is the way you have to go, 11 pyramids. In fact, when you divide this, when you divide 66 by 6, you'll get 11. Please, when you divide this by this, the answer you get is 11, and those are 11 pyramids you can go in the length. We must also see the one in the width. Now what must you know about the width? What must you know about the width? So what must you know about the width? Now about the width of the box, and this one is the pyramid. Allow me to use the letter P. So the width of the box is 24, and again the width of the pyramid is 6, because remember the base of the pyramid is like this. It is 6 here and 6 right there. So we use 6, 6. Also let's compare, we divide. So number of pyramids along the, okay, anyway, here it was meant to be width. Sorry, I've told you about network error, but shall get this corrected. Again, we shall pardon and say the number of pyramids along the width. Okay, yeah, we have it corrected this time around. So this is meant to be length, that is meant to be width, not necessarily length, which will be now 24 divided by 6. Please take note, even in this drawing, I know someone may ask, there was an error in the naming here, the network disturbed that, but this 24 is meant to be here and the 15 is meant to be there. Hope you really look into that, Andy. Okay, understand. So now with that, let's get that divided. Okay, so shall get that divided and then have, when you divide 24 by 6, shall get how many pyramids? It will give us 4 pyramids. Now we do the same. Remember, as far as this is concerned, okay, we have a box, allow me to call it letter B, and I have a pyramid, allow me to call it letter P. Now, about the height of a box is 15. Okay, what about height of a pyramid? Height of a pyramid is how much? Was 5.5753. If you can really see that. So you're going to divide again. So number of pyramids again. So you go by comparing each and every side to get the number of any stuff that brought at hand. Okay. Okay, now height. Oh, sorry. This was meant to be height still again. Told you network error. This is meant to be height. However, no worries. No worries. I hope you understand that. That's height still. Now we substitute in there. So number of pyramids along the height is equal to the 15 over 5.5753. This is for the pyramid. Of course, you know we calculated it from right here. The height of the pyramid, you have it right there. You can really see this one here. This one here. Okay. Now with that, let's go back. Now there we are. Okay. Now with that, what answer shall we get? So number of pyramids is equal to 2.7. Now one would wonder, why am I approximating it to 2? Please, when you're just calculating, you can only, now here, if it is 2.7, I see you will see that the rough approximate would be 3. It's a bit acceptable, yes, but you cannot do that on the final answer. If you're still calculating, especially using along the, like in the length, in the width, in the height, if you're still right there, then you always leave the number the way it is, because this point means that those are decimals, those are broken pieces. I don't know whether you can make those broken pieces to become a real pyramid. It's very hard. So when you are dealing with questions to do with the parking and knowing the number which can go in there, as you're calculating using length, heights, widths, and so on, the answer you get must be a whole number, like this 2.7. If you want it to be 2.9, here I would write still 2.2. I would simply write 2 exactly. Hope you really come to understand that. But if it was to be our final answer, then here it would be 3. A very good and correct answer. I hope that really makes some bit of sense to you. Okay, now with that, please have apologies. This is meant to be height. This is meant to be height right there. Now since we have that, how do we get the answer? Now you go by multiplying this by this and also by that. You simply come and do what? Multiply them. The answer you get will be the number of pyramids. Let's go there and see. So shall now say total number of pyramids is equal in the box equals to 11 times 4 times 2, and that will give us 88 pyramids without fail. Okay. Now let's continue. What is Roman number 3 saying? Let's get to what Roman number 3 is saying. Okay. Roman number 3 they're saying. Okay. They're saying are the available boxes enough for the pyramids ordered for? So like remember the boxes ordered for were 5. I don't know whether you can really follow this up. The boxes ordered for were 5. But now we want to know how many boxes are enough in a way. I don't know why this is disturbing us, but okay. Now, the ordered boxes are 5 right here. Now, but how can we make, and how many pyramids are we having in total? They are right here. 1,420. These are the pyramids we have. But now we must go and see, a box can only carry 88. Let's go back there. Now let's get this written. Okay, conclusion for the other part up is that 88 pyramids can be packed in the box. So it means that that statement there means that, I'll get this explained here. Okay, it means that one box can hold, one box can hold 88 pyramids. What about once you have 1,420 pyramids? We shall need how many boxes right here? That's what we need, and that we can get from the formula that number of boxes equals to total number of pyramids divided by number of pyramids in each box. That's what you're going to do. You can really see that, because if you multiply here, it means that you simply have to divide this 1420 by 88 to get that answer for us. Okay, so I think let's go there. With that, let's substitute. So number of boxes required is equal to 1420 divided by 88, and that will give us a 16 point. Okay, now let's explain from here. When you divide this by this, you get a 16.13. You realize that if you round off this, it cannot give you an exact, but if, remember, this is here, this one is here, is our final answer. I think it is our final answer. We are ending the story about how many are required. So this one, however much when you round off, you get 16. So long as it has some points, you approximate to 17, since this is our final answer. Okay, I think let's now do that. We have that. So number of boxes required equals to 17 boxes. As simple as that. Hope that really makes some sense. So will the boxes be enough? Remember, these people are not serious. They had 5 boxes, but look how many boxes are required. 17. So they're asking, would they be enough? Approximately no. Okay, so we conclude. We say no. We say no. The available 5 boxes are not enough for the pyramids ordered, since 1,420 pyramids require 17 boxes. So do not necessarily be enough, really. Okay, I think mathematics is enjoyable and it can help you get some of the scenarios covered right here. Now that's Roman number 3 of part A done. Let's get part B and we call it off. Just what you're going to be an easy thing. The network is a bit disturbing, but still let's go get this done and we call it a day. Okay, we're saying obtain the total commission that your sister will get from the order. Now the commission you must know here is that, okay, now about the commission you must know this about the, I don't know why this is really disturbing us. I don't know why this is really disturbing us, but allow me just use a razor pen for simplicity. Okay, now you really see that about the commission. Look, we have, now remember each pyramid is bought at 25,000. Good. Then we have a pyramid. Okay, and the company receives a commission of 12% on the first 500, on the first 200. In fact, the company receives this. Okay, I'm looking at this area here. Is what we are picking out in simple terms. That area there is what we are picking out in simple terms. Okay. Okay, and with that, I think let's go to the next part and we see. Remember, but here we have a commission of 12% for the first 500 and 80% for the rest. But remember, each is bought at 25, each pyramid. So let's go back there and we get this done. Okay, good. So let's get our table from which we are going to have this drawn. But of course, as before you go, just before you proceed, just know we have commission of 8%. This commission of 8% works on the first 500. Sorry, I think this is not 8%, but it's 12. The commission of 12%, a commission of 12% works on the first 500, and then a commission of 8% works on the excess. Excess of what? Remember the total was 1420 pyramids. So if you have picked 500, the rest will be, of course, a subtraction. And in this table we are going to have it calculated. So shall I say, but remember, the cost for one pyramid costs 2,000, rather 25,000. So how shall we get the commission? Okay, the commission is got from the given percentage times sales made. The given percentage, I write for you here, times sales made. Now the sales made means what? If you have 500 pyramids, you must multiply by the price so that you can get the sale. Then that sale you have gotten, you multiply it by this 12%, which is the percentage. Okay, let's get this done so that you can continue simply right there. Okay, now let's get this done in our table. So number of pyramids, that's what we're going to have right there. And next you're going to have the commission, and then midway we're going to have the cost. Okay, hope that makes some sense. Now number of pyramids, we are going with, first of all, let's get it done here such that we can substitute. Now really see that for the first 500, we have it here, goes with 12%. So it will be, you first of all get the cost. So the cost will be what? The number of pyramids times the cost for each. So you multiply 500 times 25,000, you get 12,500,000. Now the commission will be the percentage, which is 12 over 100 times now that commission given to us. And let's see that in the calculations. What you see in green are the answers. So 12 over 100 times 12,500,000. So this one here is the percentage times the sales made, and then the commission will be 1,500,000, like that. Now next step you're going to have now the excess. Excess means what? Excess means what you have taken so far minus the total. So total 1420 minus what you have just sold off, which will give us the 920 which are remaining. With that, let's get the cost here. So it means that will be 920 times 2,500, and that will give us 23 millions. Then of course remember the commission here was 8%. Let's get that. Okay, so 8 over 100 times 23 millions, what I'm going to have, shall have 1,840,000. So remember they wanted the total commission. So you add this plus that gives you the total commission. So shall have that there. When you add, you get 3,340,000. So when you add this plus this, you get that. So that will be the total commission. Please, they can give you commissions in 3 ways. They can give maybe 12%, 8, another like 5. That's how we go about that. This table simply simplifies it. Number of whatever they want, the cost, then the commission at the end. Okay, let's now conclude and say the total commission was. So she will get a total commission of 3,340,000 shillings from the order. Okay, as simple as that. Just know the network was a bit on and off, but we have managed to successfully get here, and that really marks the end of the Wakissha paper. Please, we simply remind you to refer to the watch right here from item 1. It is there in the playlist. Visit the channel and cross check. Please find, I might have shared this on WhatsApp or anywhere, but you can go and search that name you see there in the YouTube search button. They'll bring the whole channel. You really see. You begin by subscribing, then you will enjoy the playlist. It has a lot of very many enjoyable things. Okay, now with that, still I'm going to put for you here, after this video, I'm going to put for you the Wakissha paper, mathematics of last year, such that you watch both of them if you really have the time. So with that, I wish you well. Let's end there.